Welcome. Take out your worksheet or your yellow sheet. Give yourself a completion score for the 8.4 worksheet. Grab a red pen. Let's check your answers. Pause me if you need to. I got 34, 112, 14, and about 12.518. I wound up using a SOHCAHTOA on that little triangle to find the length of x. And I got 28, 124, 918. The secret to that 124 was realizing that that would have to be another 28 up there, just because of the symmetry is how I figured that out. So 124 to complete that triangle. 90, 45, 30, and 15. Let me know tomorrow if I messed up on anything. Backside. I went always, always, always sometimes, and sometimes always. Both of my sometimes, I only got it to work if I made the rhombus a square rhombus. Sometimes always, sometimes always, sometimes always. And for the sometimes ones, the only way I got those to work is if I made it a square rectangle. Let's go on to the new lesson. Today is Trapezoids and Kites Day. First, let's talk about trapezoids. A trapezoid, well, the definition says it's a four-sided, it's a quadrilateral with exactly one pair of parallel sides. If it had both pairs, it would be a parallelogram. But trapezoids only have one pair, and those parallel sides, we call those the bases. The sides that aren't parallel, we call those the legs. Sometimes you'll find a real special trapezoid where the legs are even congruent. We call that an isosceles trapezoid. Two of the legs are congruent. Alright, so we have a little picture of a trapezoid down here, and we're going to find out okay, it looks like a trapezoid, but we'll find out if it is. So, first of all, I want to see if it's a trapezoid. That means it's got to have parallel sides. I think if anything's going to be parallel, it would be RS and OT. And I'm not sure if they're quite parallel. How can we check for parallelness? Well, if we could check the slope and see if they have the same slope, right? So let's find the slope of RS. Let's check. It looks like it goes up 1 over 2. Or you could use the slope formula if you want to. Y minus y over x minus x. And then the slope from O to T looks like it goes up 2 over 4. Oh, but up 2 over 4 is the same as up 1 over 2, just a couple times. So yeah, guess what? It's a trapezoid. Because we found same slopes. So yes, because RS and OT are parallel. Is it an isosceles trapezoid? The only way it gets to be isosceles is if these two legs are congruent. How do we check for congruent? We need to find the length. We need to find the distance. So maybe we'll do RO first. RO is easy because you can just count the boxes. 1, 2, 3. The length is 3. And then for ST, it's slanty, so we can't just count 1, 2. So we could either do a distance formula where we take x minus x and square, and y minus y and square. Or you could just look at this as being like the hypotenuse of a 2 by 2 triangle. You with me? A 2 by 2 triangle. How long is the hypotenuse? Because that would be the same as the length of ST. Did you say 2 square root of 2? So you should get the same answer both ways, but if you wanted to think 45, 45, 90 style, you could do that. If you want to do your distance formula, it should come out the same. That's about 2.8. Oh, let's answer the question. Is it an isosceles trapezoid? Not quite. Those would have to be congruent. So not isosceles. Good times. We have some properties of trapezoids. The first one is kind of the definition, that it has exactly one pair of parallel sides. Write that on your sheet. Awesome. I'm going to put those parallels on my picture. There's another one about the angles on this one. It's kind of a cool one. Since we have those parallel lines, we can say something about those two angles. We can also say something about those two angles. Do you see how those are like same side interior? You kind of see that? So as long as we have those parallel lines, those same side interiors would be supplementary. So we can say that we have two pairs of supplementary angles, consecutive angles. Let's write it like this. Two pairs of consecutive. You could write same side. Angles. Supplementary. And that just follows from the parallel. We're going to come back to number 3 because I'm going to show you another cool thing about trapezoids. But first let's talk about isosceles trapezoids. It's just a special type. The first theorem about isosceles says if a trapezoid is isosceles, then each pair of base angles is congruent. Maybe you should add that on your property sheet. So like this angle down here is congruent to this angle down here. And the angle at the top is congruent to the angle on the top. But that only works if you check out your regular trapezoid. It doesn't work. So should we say, oh, I think I meant for that to go, I messed up. I meant for that to go on number 2. You can adapt, yes? Right, that base angles are congruent for number 2. You know what I meant to put on number 1? The definition. So it's the trapezoid, but it has to have legs being congruent. Oops. Alright, property number 1, the legs are congruent. Property number 2, those angles match. And, you know, it goes the other way too. Read this. If a trapezoid has even just one pair of congruent base angles, even if you just see one pair down there that's congruent, that's enough to tell that it's an isosceles trapezoid. Those two kind of went together. Alright, next is about the diagonals. Do you see the crisscrossy diagonals on your isosceles trapezoid? Turns out they're actually the same length. They are the same length. So just like you could measure the diagonals on a rectangle door, and they would be the same, if you were shooting for an isosceles trapezoid door, you could measure the diagonals and they'd be the same. So number 3, diagonals are congruent. Alright, and then number 4, well, it's got the pair of parallel sides, it's got the consecutive angle supplementary, it inherits all the properties of a regular trapezoid. But I haven't even told you what property number 3 is. Here's that other cool thing about trapezoids. Trapezoids have a mid-segment, and we learned about this with triangles, and it's kind of the same feel with trapezoids. The mid-segment is parallel to the bases. Well, really, it's just connecting the midpoints. Remember, mid-segment's just connecting the midpoints. So you've got tick-tick, you got tick-tick, and it's parallel to the bases, and the other cool part is that its length is related to the bases. The length is the average of the base lengths. So if we did base plus base divided by 2, you could say. Let's just try an example. So if you wanted to figure out on this trapezoid mid-segment, you can tell it's a mid-segment because midpoint, midpoint. The first thing we know is that it's parallel to those bases. And how long is it? Well, whatever number is halfway between 12 and 28. And if you can figure that out, that's awesome. Or you could do the average of those two numbers. What are you getting? 20? 20. Which kind of makes sense because it's 8 bigger than that base, and this is 8 bigger than the mid-segment. And they're equally spaced, so I think it makes sense. On the next one, it's kind of backwards because 9 plus that other base divided by 2 has to give me 12. Can you think of that? What that would have to be? Something divided by 2 to give me 12. You gotta have a 24, so how big should that be up there? Or, another way to think of it, if this is 3 longer, then that other base should be 3 longer. That makes me think 15 should work. What if I put a 15 here? 9 plus 15 is 24, divided by 2 is 12. And so we got that answer. Whatever works, however is easiest for you to figure out. Let's go back then, because what I was hoping to add for our third trapezoid property was about mid-segments. Two things about a mid-segment. Do you remember? Mid-segments are parallel to the bases, and something about the length, right? And should we say average of base lengths? Does that make any sense? Something like that. And now since the trapezoid has that property, it's also going to work down here on the isosceles trapezoids too. Still parallel, still the average of those two lengths. Beautiful! Kites. Let's whip through this. A kite looks like that. And it's a quadrilateral with 2 pairs of congruent consecutive sides, but opposite sides are not congruent. That just means that you have to have 2 in a row that are congruent, and then the other 2 in a row congruent, but not the same congruent. Otherwise it would be, if all 4 were the same size, it would be a rhombus. So property 1, 2 pairs of congruent consecutive sides. Number 2, if a quadrilateral is a kite, then its diagonals are perpendicular. Who else do you know that has perpendicular diagonals? A rhombus. Very good. And number 3, if you have a kite, then you have 1 pair of opposite angles congruent. Do you know which one? Do you want to mark it on your kite? Swoop, swoop. Awesome. Let's see if I have time for one little example. Find the measure of angle F. I feel like if I knew angle F, then I'd know angle D, or vice versa. Could we figure out both of those? Do you know what all 4 angles have to add up to? If we took D and F, and the 124 and the 80, what do all 4 angles in a quadrilateral add up to? N minus 2 times 180 should add up to 360. 4 right angles would make that. So that means that these 2 angles, if you subtract those over, are going to add up to, what do we have here? 204. So you subtract over 204 and you get 96. So those two, 40.